so we were on question 18. Let's start with that. The two random variables are already mentioned in the question. So find the probability that an observation from the find the probability that an observation from the population of X. So we need to translate this into a math equation. Probability that an observation from the population X is more than twice the value of the observation in Y. So how would you write this down? Observation from X is more than twice the observation of Y. How would you write it down? X is greater than 2Y. That's your inequality. X is greater than 2Y. An observation from X is more than twice the observation from Y. Now see, this is not Y1 plus Y2. This is clearly 2 times Y. If it would have been Y1 plus Y2, you would have said the X, an observation taken from X is more than the sum of 2 observations taken from Y. So here is saying twice the observation, it's 2 times Y. So this implies X minus 2Y is greater than 0. So we say let maybe W equals X minus 2Y, we call the new random variable W, and then we are interested in the expected value of W and the variance of W. See the description of X and the description of Y is already stated. So can you give me the expected value of W now? That would be X minus 2 times Y. That would be 100 minus 2 times 55. Which is how much?
Negative 10.
Negative 10. And variance would be 8 plus 2 square times 10. Remember, the multiple goes outside in squares and then multiplies. We've already discussed this. So this is 48. So the variance is 48. So we'd say W also follows a normal distribution with mean minus 10 and variance 48. Right? And what do we need to find? We need to find the probability that this is happening, which means we need to find the probability that W is more than 0. Let's make the sketch. So the mean is minus 10. So where would 0 be? On the left side or on the right side? It would be on the right side. 0 is going to be here. We want W to be greater than 0. That means we want the right side area. Do we agree on this? Right. So what's the next step?
Z value.
Get the Z value. Let's get the Z value. One point 1.443. Guys, check. It should be 1.443. There was one case also the combination wasn't following the combination. It wasn't multiple. It was combination. Poisson's combination doesn't follow. Doesn't follow Poisson's distribution if the random variables are multiples. Because the mean and the variance doesn't match. Should we check the table? 1.443. Let's check the table for 1.443. 1.401234. So 1.44 is here. This is 1.44. 1.443. So 1, 2, 3. Add 4 to it. 0.9255. Can you all see that? 0.9255. So this area is 0.9255 and this one
0.07.
0.0745.
0745.
That's the answer. 1 minus 0.9255 is the area that we require. Right? Are we all good? Shall we move on? Any questions? Last question, then we're done with chapter. Okay. Please read the question carefully. The values are already given. In the first part, they're saying a bottle of each size is 70 grams. That means one bottle of small and one bottle of large. Find the probability that the large bottle contains less than 4 times the amount in the small bottle. The large bottle is less than 4 times the amount in the small bottle. How do you write this down? L less than 4s. Let S be the random variable for small and L for large. So this implies L minus 4s less than 0. So let's say L minus 4s is a new random variable. So let's call L minus 4s as x, the new random variable. So what would be the expected value for x? That would be 1012 minus 4 times 252. Is that 4? The expected value is 4. What would be the variance? The variance of x would be L, that's 25, plus this 4 becomes 4 square times 4. So what's the answer? 89. So x also follows a normal distribution with mean 4 and variance 89. Is everyone with me till here? At the back, are we good?
Yes.
Okay. Let's make the sketch. So what do we want? We want the probability of x to be less than 0. That's what we require. That's what we're trying to find. Mean is 4. 0 is definitely on the left side. This is the area that we want. Less than 0. Let's find the z value.
Minus 0.4.
Minus 0.4. Minus 0.424. Should be doing this. So let's check the table for 0.424. 0.424. 0.424. That means add 14 to it. Can you see that? So it becomes 0.6632. 0.6642. Yeah. Add 14 to it. 0.6642. Can you all see that? Okay. So this area is 0.6642. We require this one.
0.335.
That's 1 minus 0.6642.
0.335.
13358.
So
It means
the vacuum one.
for the sake of final answer should be 0.336. Sorry? Because the table always gives you the body area. We want this tail area. So the body area is 0.6642. 1 minus will give you the tail area. Everyone's okay with part A? Any questions? Okay, let's try part B. Yeah, can I just clear this stuff here if everyone's done with it, because I want to do part B over here. Is everyone done with part A? Right, so what's happening in part B? In part B, if you read the question carefully, one large bottle and 4 small bottles are selected random. Here see, he said a bottle of each size, I mean one small and one large was taken. So one large and 4 small bottles are selected random. Find the probability that the amount in the large bottle is less than total amount in the 4 small bottles. So the amount in the large bottle is less than 4s.
S1 plus S2.
This is S1 plus S2 plus S3 plus S4. Last time it was 4 times the amount in the small bottle. This time it's one large bottle less than the sum of the amount of 4 small bottles. So this is less than S1 plus S2 plus S3 plus S4. I hope we can see the difference between the two wordings. So this implies L minus S1 plus S2 plus S3 plus S4 is less than 0. So let's say X is the new random variable L minus S1 plus S2 plus S3 plus S4. X is the new random variable. And what would be the expected value of X? It would be 1012 minus 4 times 252, because all of them have the same mean, 252. So the answer is 4. See, it doesn't make a difference to the expected value, but it will make a difference to the variance. Variance of X would be variance of L, that is 25, plus, because the minus one goes out and becomes plus, the 4 variances added, which is 4 plus 4 plus 4 plus 4, so it's basically 4 times 4. Last time we did 4 square times 4. Yeah, what's the answer? 41. So we say X also follows a normal distribution between 4 and variance 41. Right? Let's make a sketch. Mean is 4, and we want the probability. We want the probability of X to be less than 0. 0 is on the left. We need the left side area. Let's find the Z value.
Minus 0.6265.
Minus 0. Minus 0.65. Are we all getting that? Minus 0.65. Let's check the table. 0.625. 0.62 is right here. And if we go further, 1, 2, 3, 4, 5, 16. We need to add 16. 0.73. 0.7340. This area is 0.7340. This is the one that we require, that's 1 minus 0.7340, which is 0.266. That is your answer. Are we good? Any questions? Let's do one past paper question. Okay, so this is June 14, reading 3 question. Okay, let's try this out. This is June 14, reading 3 question. It's on linear combination of random variable. So the two random variables description is already given in the question, x and y. You may assume that each candidate's marks in the two papers are independent. The final score of each candidate is found to be calculated as x plus 2.5 times y. They've already given the relationship as well. Without using a continuity correction, find the probability that this candidate has a final score that is greater than 140. So, x plus 2.5y becomes a new random variable. Let's call that random variable w. So w is x plus 2.5 times y. What do you think is the expected value of w? Or what do you think is the variance of w? First of all, let's do that.
Expected value would be 75.
Hmm?
75 would be the expected.
Okay, expected value would be 75 and variance? Variance would be 13 plus 2.5 square times 5. 44.25. What do we want? We want the probability of W
Greater than 140.
to be greater than 140. Mean is how much? 75, 140, definitely
So that's 75.
पता नहीं बताएंगे कितना है?
So 127.
127. Okay, 127. Okay, so we want the probability more than 140, 140 on the right, we want the right side area. Let's get the z value. What's the z value?